Okay, guys. Experiments today is about alcohol, alcohols, and phenols. We'll have 4 alcohols, 1 phenol, and 1 unknown. So the whole idea will have 4 alcohols, 1 phenol, and we'll have unknown. Now you have to take only 1 unknown. Unknown can be A or B or C or D. You don't have to test all of them, just one, take one. So you decide B, then you take only B. Okay, guys? So first, just a little bit of theoretical background. The alcohols, anything that has connected the OH. So this is an alcohol. You have an organic rest connected to hydroxy group. Hydroxy group means alcohol. So with this in mind, we have to differentiate between 3 different of alcohols. We have primary, secondary, and tertiary alcohol. So this is called primary. This is called secondary. And this is called tertiary. So 3 types of alcohols. Let's look at those types together and how we can differentiate all of them. So the primary alcohol is the alcohol that's connected to one group. To what? To one group. So this one here, OH, and then whatever R here. So this, if you look at this, H, OH, and R. One group. So the OH, the hydroxy group here, connected to the carbon that carries the OH, is connected to what? To 1. This carbon here carries this, and it has only one functional group or one alkyl group. Okay, so one alkyl group. So this is called primary. Now I can replace one at a time those hydrogen. I have a secondary one. Then I will replace CH, R, H, OH. So if I replace now one of the hydrogen, correct? This is R. This is my OH. Now this is another R. This is H. I have how many R's? 2. That's secondary. How many R's? Secondary. Now I can replace the last H here. That would be tertiary. So then I replace the other one, R, instead of H, R, OH. Now I have OH here, and then I have R. That's called tertiary alcohol. Okay, guys, tertiary alcohol. We'll test today those 3 and how to distinguish between them chemically and physically. So this is the three types of alcohol, depending on how many alkyl groups attached to the carbon that carries out the OH. Correct? So I have three. Tertiary, if I have two groups, alkyl groups, that's secondary. If I have only one group, that's primary. Correct? So this is said and done. Let's go to the phenol. The phenol is totally different. Phenol is not like an alcohol. Phenol has a benzene ring. With the OH. Since those three are moving around, correct? They are moving around. So we can say this one here just a loop, because those three double bond are not. So this is phenol. Those three double bonds within the cyclic ring, they are not fixed in space. They are moving around in a loop. So we put the loop inside of this three double bonds that we know they are not localized, they are delocalized, they are moving around. So the phenol, you can expect, because the benzene ring is always chemically inactive, correct? So you can see that most of the reaction easy on the alcohols will be difficult on the what? On the phenols themselves. Correct, guys? So those are the ones you can see the difference between them. Now, the alcohols can be attached to it some substituents, some alkyl groups as well, but the whole body, the whole structure here is still phenol. So we can have three types. Here it is. Another type here. So the attachment can be, this is one, of course, always, 2, 3, 4, 5, and 6. Correct, guys? So if you look at this, we can have two of them. We can have a group here, R. We can have group R. We can have group R here. So you can always number them. Always what? Number them. Whatever R is, you know, that's your number 1, and it goes by the alphabets of the alkyl group. Correct? So if I have here, this R is a methyl group, and this is ethyl group. The E, the ethyl group, which is CH3, CH2. The E will come before the M. So your numbering will be not the case here. So we have to number them quite the opposite. Correct? So will be our, this is 1, this is 2, this is 2, this is 3, 4, 5, and 6. Why? Because the E comes before the M, methyl. Correct? So that's, you have to watch for the substituents on the phenol ring according to the alphabet. It goes the numbering according to the alphabet. So if you have an alphabet that has A, so the A will take over the E and the M and so on. Okay, guys? So now let's go for the chemical reaction we will do. Okay, guys, so you will have out of this here, you will have 6 test tubes, okay? So 6 test tubes. 1, 2, 3, all the time use 6, 4, 5, and 6, guys. So let's label them. 1, 2, 3, 4, 5, and 6. Okay, guys? 6 what? 6. As I said, stop talking. The same old people still the same thing. I have to split you out. You cannot work together from now on. Today, no work together in a group. 2 of you in the back, please. You cannot work together because you show a lot of disrespect while your professor is talking, and you show disrespect. Talking from the day you come in, the second you come in and start talking. That's not good. So you are not allowed to work together. Find yourself another group. I'm sorry, but I can't help it. So we'll have 3 of those here. Alcohol. This is phenol. Correct? Those are alcohol, this phenols. This is your unknown. This is your phenol. And this is, let's belong to alcohol. We'll take 4 of them. So 4 of those alcohol. Okay? Each time you'll add, you said 5 drops and 10 drops. Be consistent. 10 drops. 10 drops is half a milliliter. So a milliliter is 20 drops, around 20 drops. So if you take 10, that's roughly half milliliter. So you will add your alcohol here and your phenol here, and all this addition here and all of them here. It's 10 drops. It says sometimes 5, sometimes. Be consistent at 10 drops. Correct? And you'll add the same thing, 10 drops of your compound. So add this one here. That's a phenol here. Number 5, 6. That's your unknown. You have to select A or B, whatever you like. Just one. Stay on the one. Or C or D. One of them. You stay on that one, please. Do not do all of them, no. So you'll add 10 drops, and the first easy one, you do what? The solubility. The solubility, correct? So you'll add H2O, maybe H2O as a sulfate, maybe 2 drops, 20 drops, that's 1 ml. 20 drops H2O, the first test for all those, including your unknown, correct? Including your unknown. And then you will see if it's 1 layer, that's soluble. If it's 2 layers, one looks like oil in the top, floating, and the H2O is sinking. It's higher, more dense than those alcohols. So then you will have, except maybe tertiary, then you can tell about the solubility, correct? In general, solubility always controlled by the number of carbon of alcohols. The smaller alcohol, the higher the solubility. Like we have methanol. This is methanol, or the commercial, the common name is methyl alcohol. Methyl alcohol. But the IUPAC naming is methane, take the E out, OL again, methanol. Correct? That's highly soluble in H2O. Correct? That's highly soluble. Ethanol, 2 carbons, that's 1 carbon, 2 carbons. And are those primary or secondary or tertiary alcohol? Somebody will tell me? Somebody? Methanol and ethanol. Primary, secondary, or tertiary? What do you think? Well, look at this. This is one group. This is connected, still one group if you look at the whole thing. Correct? So those both are primary. Because you don't have the carbon that carries out the OH has only one group. The carbon that carries out, there is no one, that's one group. So those are primary alcohol. If they carry 2, the carbon carries OH, has 2 groups, that will be secondary. If it has 3, will be tertiary. So first of all, the H2O, the solubility. You will see those alcohols are highly soluble in H2O, the smaller ones. If you go higher and higher, the solubility will be limited. So tertiary alcohol, for example, tertiary alcohol has three groups. R, that's tertiary. OH is here, correct? Three groups, that the solubility will be very limited. Depending on the R size, it will be not soluble. Correct? Depending on the R size, it will be not soluble. So that's the first solubility test. Okay, guys? Everybody agrees? Let's do the other one. Those are type of not chemical, but that's type of physical approach for the testing those alcohols and phenols and the unknown. So next is to take 10 drops, but you will not take anything with this. You take 10 drops of each alcohol and phenol and the unknown, and try to smell. We want to see the odor. So we test the odor of them. The odor of them. Okay, so we test the odor of them, and you can tell that the general alcohol, they'll smell nicer, correct? The phenols, they don't smell very good, but they have distinct smell. And you can always relate smell to something you can visualize. Smell the odors, like odor of red rose, for example, odor of whatever. So always related to something is you are familiar with. So you have the same thing here, 10 drops each. We smell the whole smell. So two physical approach, the odor and solubility. Now we'll go for the physical. The physical will do some reaction to distinguish the alcohol, the phenols from all those four, which is we'll be using zinc chloride and HCl. Zinc chloride is a catalyst, and we'll use HCl. What will happen here? The phenol will react, the other ones will not react. Okay? Or they react very, very slow. They take time to react. So that's one. The second one, we'll do the oxidation. Oxidation. Phenol will not oxidize very easily. We'll do chromic acid. Chromic acid is an acid that has sulfuric acid in it, very, very highly toxic compound. And you will see that those alcohols, the primary alcohol will give you what? Will oxidize to carboxylic acid through the aldehyde. The secondary one, if you have a secondary alcohol, will be oxidized to what? To ketones. So the primary goes to aldehyde, carboxylic acid. The ketones, the secondary goes to ketones. The tertiary is not oxidized, cannot be oxidized, unless you are combust the whole thing together. Correct? So we did the zinc chloride with HCl, we did chromic acid oxidation, and then you can do with the permanganate. Permanganate will be easy to oxidize alcohols. Will not oxidize what? Permanganate, another oxidizing agent. Correct? So we are using chromic acid to oxidizing agent, and we are using chromic acid, and we are using permanganate. Permanganate is a very strong oxidizing agent. So let's go here and look one at the time here. You can read all the stuff here. So here it is with chromic acid. If it's always changing to greenish color, there is a reaction. If it stays like this, you know, that's not this is chromic acid oxidation. Chromic acid oxidation. Chromic acid you get dichromate or just chromate sulfate in sulfuric acid. It's highly toxic oxidation agent, so you have to be careful. Thus, you can differentiate between the alcohols, secondary or primary. Correct? The secondary will give you what? Will give you first aldehyde, a very distinct smell, and then go carboxylic acid. The smell will disappear a little bit. Then the other one, the primary, will go to ketones, a very distinct smell as well. So you can see here, this is the color with chromic acid. So if you look at this color here, so this is chromic acid test with the three ones, with primary, secondary, and tertiary. Tertiary remains as is, no reaction. But this one here, when you oxidize it, you get what? Aldehyde first and then carboxylic acid. This one here, you get ketones. So this one get ketones. This one here, aldehydes. And then from aldehyde, carboxylic acids. Tertiary here, no reaction. Okay, guys, this is with the chromic acid. Chromic acid is a very corrosive combination of two compounds, chromate or dichromate, with sulfuric acid, concentrated sulfuric acid. So this is the reaction here we are doing. Okay, guys. So let me see if we have any reaction there. Okay, so that's the primary alcohol and ferric chloride. Okay, so this is typical ferric chloride, typical for what? For phenols. Ferric chloride makes a complex. This complex looks like this here. There's a formula. You don't have to memorize the formula. This is the formula of the complex, called complex ion, which is here. The ferric has 3 plus, and the phenol, it has, take the OH out of it, that's negative. Correct? And then they react together with 6 of phenolate. This is called phenol ATE, phenolate ion. We took from the phenol the OH, the hydrogen out, and we get phenolate. Correct? So you react it with 3, so you get then iron, and then and the whole thing is 3 minus. This is 6 of them, so 6. So iron 3 phenolate, which is, looks purple, type of the violet purple color. Okay, guys, thus we distinguish for very distinct reaction for what? For phenol. That's a very distinct reaction for phenol, and this is giving purple to violet color. Correct? Now, with all other alcohols, there is no reaction. Iron chloride does not react with that. Primary, secondary, tertiary alcohol. Iron chloride, iron trichloride, it reacts with phenolate of the phenol molecule. Okay, guys, so again, you will do what? You will do 6, same thing we did, your unknown, 4 of alcohols, 1 phenol, and then you test, you add ferric chloride, couple drops, maybe 3 to 5 drops, and see what? You see the reaction. If it's, the phenol is so sensitive, it will come out as purple to violet color. So this is how to Again, this is not an oxidation, guys. This is not an oxidation. This is just a complex formation. So other reaction here, I'm just looking for the other reactions here. So the iron chloride is for phenol, and the chromic acid for primary and secondary, correct, reaction. And you can see the color, the primary and secondary and tertiary. So you can eliminate the tertiary out with this chromic acid. And the secondary is darker, very darker green color, very dark green color. Then you have this reaction with zinc chloride and HCl called Lucas test or Lucas reaction. And you can see when you add a couple of drops of Lucas test, which is zinc chloride and HCl, the zinc chloride has nothing to do with the reaction. It's a catalyst. HCl does the whole reaction. And you can see here, you have those primary, secondary, and tertiary alcohol, not the phenol. Phenol with iron chloride, iron trichloride, give you purple violet color. But here you're going to differentiate between those three, the primary, secondary, and tertiary. You can see that with the zinc chloride, which is a catalyst with HCl, you can see the reaction will come with what tertiary. Tertiary is a reaction. You can see tertiary here from the beginning, after 1 minute, after 10 minutes, after 15 minutes. You'll find it what? You'll find after 15 minutes. Tertiary, it's typical for tertiary alcohol. For primary and secondary, it takes long, very, very long time, hours, to see any type of precipitation. Okay, guys, so I don't know why they give you the zinc chloride. I have to do it for you. Try to do it. It's not really difficult. You just take zinc chloride, HCl together, and then add a couple drops of this into those alcohol, primary, secondary, and tertiary alcohol. Correct? Primary, secondary, tertiary alcohol. It said the demo was done by a professor, but no need. You can do it yourself. Zinc chloride is the catalyst, and the reaction is with HCl. Then the tertiary will react only. Tertiary alcohol will react. Everybody still remembers what tertiary alcohol looks like? Let me repeat again. If I have, here is my OH, and here is my R, and this is H, that's called what? Primary, one group. Then I go here, I said, well, let's take one of those H out, add R here, and here H, and here's my OH. That's called what? Two groups. That's what? Secondary. Then if I say, okay, let's replace this one here as well. So R, OH. That will be then, this is secondary, this is tertiary, this is primary. Two H's, one R, two R's is primary, three R's tertiary. So, solubility in H2O, as you said, solubility in H2O, we talked about this. You will see the solubility of H2O, alcohol in general, small tiny alcohols, methanol, ethanol, up to 5 carbon. 6, then you have problems. Hexanol, barely soluble. Hexanol is barely soluble. Okay, heptanol is not soluble, but methanol, 1 carbon, highly soluble. Ethanol is soluble. Propanol is soluble. Then the solubility decreases until number carbon 6. You have a difficulty to dissolve this alcohol in H2O. Everybody is following? So that's the solubility of H2O. With this Lucas test, I want you to do it. You can do it yourself. Why the instructor has to do it? But you can do it yourself. I think everything is there. Just take those test tubes and add Lucas test to all of them, and you will see that the best results will give you for tertiary. Tertiary will give you immediately precipitate. The other ones you have to wait for them for a long time. They might even not, if the reagent is diluted, you might not see any precipitation. So, solubility in H2O, all alcohols, depending on the amount of the carbon. So tertiary alcohol, if it's too large, too big, it's not soluble. The smaller the alcohol, the higher the solubility. And the phenol is soluble in H2O. It should be soluble. Why? Because it has hydrogen bond. Did you hear about hydrogen bond? Hydrogen bonding? So hydrogen bonding is very important in the solubility. So they bridge themselves with the OH as a solvent, making hydrogen bond. So phenol is hydrogen. The last reaction is, somebody will tell me, you should tell me, what's unique about phenols? About phenols, we use it in the bathrooms, cleaning up the bathrooms, especially that's used in the bathrooms. And you have to keep it out of the reach from any child of yours. Phenols are weak acids, so we have to test. All alcohols, they are neither nor. They are not acids or base. They are neutral. All the alcohols, primary, secondary, tertiary, are what? Neutral. When it comes to phenol, and that's what kills the bacteria inside the bathroom, it's acidic, weak acid. Weak acid. And if you have it, a concentrated amount of it, a weak acid can kill all the bacteria inside the bathroom. And you have to keep this bottle out of the reach of children. Very highly aggressive compound phenol. So acidity, you will take all of them here, all the test tube, and then you will have a solution made of phenol phthalate. It's an indicator, sodium hydroxide. So you take a solution that's pink to begin with. You dump it in all those test tubes. So you take sodium hydroxide and phenolphthalein. That will give you pink. All the alcohols will not give you no reaction. But when it comes to put it in a phenol, guess what? The pink color of sodium hydroxide inside phenol will disappear. It means phenol is acidic. And that's the reason we are using it to clean up any bacteria inside the bathroom. That's why we have to keep it out of the reach of any children around. So children not around this compound. It's a weak acid, very aggressive weak acid. So we did the solubility here. We talked about the acidity. Acidity, you take phenolphthalein in sodium hydroxide. The solution is pink. When you put it inside all those alcohols, the pink color will stay pink. But when you put it in the phenol is weak acid, the pink color will disappear. Okay? The pink color will disappear. So, the odor, the acidity, ferric acid, that's for phenols, the purple to violet color, oxidation. So, oxidation with chromic acid, as I said, chromic acid can oxidize the primary and secondary, and tertiary cannot, and the phenols are not oxidized, they are not oxidized by chromic acid. Correct? Now, the combustion reaction is not there, but all those compounds are combusted inside what? Inside the flame. If you have a Bunsen burner and you put them, just hold on, put them in, with the flame and you burn them, all of them will burn. But what's the difference between all of them? They burn equally? No. A phenol will what? Has benzene ring. It will what? Give you soot. So the phenol is not combusted 100%. It's partial combustion. The primary, secondary, and tertiary alcohol, they will combust easily. They give you CO2, H2O. But the phenols burned inside the flame, the presence of oxygen, it will give you, besides CO2, H2O, it will give you a lot of soot. A lot of dark carbon particles are not combusted, not converted into carbon dioxide. Are you following me here? So I think that's the whole idea of the lab. and just fill in your grade. So now I'm open for any question. Yes. No, no, that's not. Every time you use, how many you have? You have 3 alcohols, correct? Primary, tertiary, primary, secondary, tertiary, 3 alcohols, 1 phenols, and 1 your unknown. Those should be 5. But the name of alcohols here you'll be using, they are given to you here. Look, guys, can you see that? This one, different information? Okay, but this is the one we are using. So here it is. Here it is. 1, 2, 3, 4, 5. Correct? So those are 5, and your unknown is 6. Unknown. Now, how you get your stuff, guys? Let me show you now. Let me show you where to find the material here. So this is the unknown here. So no, that might be, I did not try those procedure. You use the 6 test tube all over, every time. Be consistent. The alcohols, you have ethanol, 2-propanol. That's ethanol is primary, 2-propanol is secondary, 2-methylpropanol, that's tertiary. Then cyclohexanol, that's cyclic, that's added. That's cyclic what? So here, the only thing they added here. So those are first. This is let me see here. So here it is. Let me write them here for you. So ethanol, CH3, CH2. I'll show you where to find yours. So that's ethanol. 2-propanol means CH3, COH, CH3, and here H. Okay? 2-propanol, 2-methyl, that's 2-propanol, correct? And then you can take the H out, CH3, COH, CH3, CH3. That's the third one. This is number 1. Number 2, again, 1, 2, 3. Now number 4, and this is number 5. So 3, 4 is cyclohexanol without the ring, so without the loop. This is OH. And the phenol is with the loop. So this is 4, this is 5. And then number 6 is your unknown. Now, I don't know from where you are getting your information, but I'll show you. Where is it here? Instructor. I don't really see it, but flow procedures in highlighted. Instructor demonstration, Lucas, okay? Sample Lucas test result and see videos, demonstration. Measure 2 mL of reagent. 2 mL means what? The ml is 20 drops. 2 mL is 40 drops. So this, guys, this is 40 drops. into 5 labeled test tubes. Do we have 5 labeled test tubes? No. I said every time use 6 because those are the ones given to us. 1, 2, 3, 4, 5, and the unknown number 6. Ignore whatever typo they might have. I'm telling you, use what? 6 until you end the whole experiment 6, 6, 6, 6, 6. Because you have to test all of them to be persistent and the same track. Use 6 test tubes. Don't use 8 or 9 or 10, whatever they're saying. That might be a typo. I don't know. I did not write this one. But anyway, they are giving us 5 for alcohol, and 1 is cyclohexanol, cyclic alcohol, and 1 aromatic alcohol called phenols. This is cyclohexanol without the loop. The loop is phenol. And then our unknown. All the time, take how many you said? 6. Whatever said 8, 9, 10, 5, 3, no. All the time 6, because you have to be consistent in order to get your unknown correct. You have to be consistent, taking 1 at a time, 1 at a time. All the 6 test tube, all the 6, including your unknown, give them the same type of treatment, chemically or physically, correct? So I'll show you how to get those. But that's not correct. You don't need to take 8 or 9 or 10 test tube. That's a typo. Okay. Yeah. Just cool yourself down. It's all the time. Cool yourself down. Okay. Cool yourself down. Okay. Cool yourself down. There are some typos there. I mean, the person who had written that is a human, not a machine or robot or something. So that's from where it came out, the 9 test. We have 9, we have 5, and 1 unknown, 6. Where's the other 3 came from? So just all the time, cool yourself down. So guys, I'll stop here. If you have during the experiment any question, come and see me. Meantime,